Welcome to Chapter 4, Section 7. Here we're going to learn to classify numbers, and specifically we're going to find out how do I determine if a number is rational or irrational. Vocabulary, irrational number, real number, and the density property. Biologists classify animals based on shared characteristics. The cardinal is an animal, a vertebrate, a bird, and a passerine. You can see this shows kind of a diagram of how that fits in. You already know that some numbers can be classified as whole numbers, integers, or rational numbers. Recall that rational numbers can be written as fractions. Rational numbers can also be written as decimals that either terminate or repeat. Below are some examples: 3 4/5, or 3.8, 2/3, which is 0.6 repeating, the square root of 1.44, which would equal 1.2. Irrational numbers can only be written as decimals that do not terminate or repeat. If a whole number is not a perfect square, then its square root is an irrational number. So for example, the square root of 2 equals 1.414, etc., repeating on and on and on, different numbers, so there's no pattern. A repeating decimal may not appear to repeat on a calculator. Because calculators show a finite number of digits, if it repeats after so many digits and it's not visible, it's possible that it is a rational number. You'll have to do your best with what you can work with. The set of real numbers consists of the set of rational numbers and the set of irrational numbers. So there are real numbers and there are not real numbers. We don't work with anything that's not a real number, but take a look at the two categories under real numbers: rational and irrational. You can see irrational has some examples, but no other numbers fall into that category. Where under rational numbers, that also contains integers, whole numbers, and natural numbers. So working your way from inside out, if you're a natural number, for example 1, 2, or 3, then you're also a whole number, and an integer, and a rational number, and a real number. So when we classify, we need to classify under all of those categories. So let's take a look. The chart is in the bottom right-hand corner to help you out. Write all names that apply to each number. The square root of 5. 5 is a whole number that is not a perfect square. That is something we read about earlier. That means that it's an irrational number, but irrational falls under the category of real, so we would classify it as both. Negative 12.75. That looks to me like it has a terminating decimal, so it ends. So that means that it fits into a rational category. It's not an integer because of the decimal, but it is also real. Example C, we have a square root of 16, which simplifies down to 4. 4 divided by 2, which equals 2. That gives us a natural number, which means it's also a whole number, an integer, a rational number, and a real number. So we have all 5 categories for the number 2, letter C. Square root of 9, we can simplify that down to 3. So 3 would be a natural number, whole number, integer, rational, and real. Negative 35.9, that's a terminating decimal, so it would fall into the category of rational, which is also real. Last example, negative 81 divided by 3 would equal 9 over 3, which equals 3, which would be again all 5: natural, whole, integer, rational, real. It's important that you include all categories that it is a part of. Here we just want to look at rational versus irrational, or not even a real number. So square root of 21. 21 is not a perfect square, which means it's going to give us an irrational number. 0 divided by 3 equals 0, and so 0 would be a rational number. 0 can be written as a fraction. You can also see it's part of the whole numbers, integers, rational numbers group. Square root of negative 4. We discussed how that's not possible, so if it's not possible, it cannot be a real number. So this would be an example where you have not a real number. It's something that's not going to work in your calculator. Square root of 4/9. Remember, you can break that apart to do a square root of 4 and square root of 9, which is the same as 2/3. So 2/3 is rational. Lastly, the density property. Density property of real numbers states that between any two real numbers is another real number. This property is also true for rational numbers, but not for whole numbers or integers. So for instance, there is no integer between -2 and -3. Think about whole numbers. There is no whole number between 1 and 2, 2 and 3, 3 and 4. But with rational, we can have decimals, so we can extend out a lot of digits. Same thing with any real numbers. So if we need to find a real number between 3 and 2/5 and 3 and 3/5, we have many solutions. One solution is halfway between the two numbers. So to find that, we take the average by adding the numbers and dividing by 2. 3 and 2/5 plus 3 and 3/5 is 6 and 5/5, which is the same as 7, and 7 divided by 2 is 3.5. So that would be a real number between those two values. And you can see, looking at a graph, it would fall halfway in between. Let's try another one. Find a real number between 4 and 3/7 and 4 and 4/7. So one route is to divide the two numbers once you've added them together. So add them up. 8 and 7/7 or 9. 9 divided by 2 is 4.5. That would be between the two values. That's it. Make sure your notes are filled out completely. Take some time to come up with some good questions and try to level them. And make sure your notes are highlighted, underlined, and complete the summary before class.